So we have done operations on rational expressions. We've done equations with rational expressions. Now we get to do one of my favorite things. And this is going backwards. This is, we start with a fraction, with a rational expression, and then we pull it apart and say, well, what are the rational expressions that will add or subtract to get us that rational expression that we have? So what do I mean by that? Essentially, we're going backwards. Let's take an example with numbers, okay? So suppose that we have 4 over 6. So 4 over 6 can be broken down into 2 over 6 plus 2 over 6. But it can also be 1 over 6 plus 1/2, which is 3 over 6. It could be negative 1 over 6 plus 5 over 6, also 4 over 6. It could be 1/3 plus 2 over 6. Okay, so the problem is that there's so many ways of doing this, right? Just for this 4 over 6, there are many different ways that we could break this down. It's even, let's say that we had the number 10. How can we get to the number 10? There are an infinite number of ways to get to the number 10, especially when you include negative numbers and subtraction. The thing that's really cool is that this is one of the areas where algebra is actually easier than numbers here. Because in algebra, there's only one way. And that makes this so much simpler, okay? So in rational expressions, rational algebraic expressions, there is only one way to get to our answer. So when we talk about partial fraction decomposition, what we're doing is we're saying, how can we write a rational expression as the sum of simpler rational expressions? So let's write that down. And again, there's only one sum for every rational expression that we have. So we're going to start by looking at this with proper fractions, okay? And that's because it's not that it's really more complicated with improper fractions. It's just that it creates an extra step, okay? So a proper fraction, for those of you who do not remember from elementary school, the numerator is less than the denominator. Now, algebraically, that might be hard to see, so we look at the degree. the degree of the numerator is less than the degree of the denominator. Okay, 4/6 is a proper fraction if we're just talking about numbers. X squared over x cubed is a proper algebraic fraction. Okay. So let's just take some examples and do it, because that's, again, the easiest way to learn this. Okay. So let's say that we have x plus 7 over x squared minus x minus 6. And we want to write this as the sum of simpler rational expressions. So first step, you want to factor the denominator as much as possible into linear and quadratic factors. So in other words, it could be x plus 1, x minus 2, x minus 7. These are all linear factors. X squared plus 1 might be a quadratic factor, okay, where you have 1 with an x squared. This is not considered factored as much as possible because x squared minus 6, we can factor more. X squared minus x minus 6. It can be factored further, and it can be factored into linear factors. Linear factors are all easier to work with, okay? So when we do this, again, if you need help with factoring, go back to the quadratics 1 video from a few weeks ago. X squared minus 6 factors to x minus 3 times x plus 2. So our first step is to factor the denominator as much as possible So as much as possible is really important here. You can't stop just because you see a quadratic. You have to make sure that that quadratic isn't factorable. Okay, so here's what we do next. We're going to create a fraction for each factor. Where the denominator is the factor. And we're going to practice this a lot over the next 2 videos, so don't make yourself crazy. Okay, so where the denominator is the factor and the numerator is either a constant, we'll call it A for now, if the factor is linear, or in the form ax plus b if the factor is quadratic. Okay, so what does that mean? That means that x plus 7 over x minus 3 times x plus 2, notice we're using the factor denominator. We're going to create a fraction for each factor. So there are two factors here. There's x minus 3 and x plus 2. So we have two fractions. In the first fraction, we have the first factor as the denominator. In the second fraction, we have the second factor. Okay. The order of this doesn't matter because this is addition. Addition is commutative. This is multiplication. Multiplication is commutative. You'll wind up getting the same answer. Okay. So in other words, if x plus 2 were first, that's fine. Okay. Now to get the numerators, we're going to look at each denominator and we're going to say, is it linear or quadratic? X minus 3 is linear. There's no x squared. It's linear. So the numerator is just a constant. So in this case, we'll call it a. Now we go to the next one. X plus 2 is linear. So the numerator is a constant. We already used a, so we can just use b. So don't use the same letter twice. Okay, we'll practice how to get the numerators with other problems, but let's finish this problem first so that you see how it works, okay? So the next step is to multiply both sides by the denominator of the original fraction. In factored form. So don't go back to your very first step. You're basically saying multiply by the denominator of the fraction on the left. Okay, so in other words, you're taking this and you're multiplying by x minus 3 times x plus 2. And then you're taking this and you're multiplying by x minus 3 times x plus 2. Okay, let's look at what happens on the left. On the left, we have x minus 3 times x plus 2, but then we have the same thing in the denominator. So this just cancels completely. So we get x plus 7. What we are doing is we are hoping to get rid of all the denominators. When we distribute this, this does get distributed. For this first fraction, the x minus 3 will cancel, and all we're left with is a times x plus 2. And then for this one, the x plus 2 cancels. So all we're left with is b times x minus 3. Your next step is to solve for the constants. So just as a review up until this point, first thing that we did is we factored the denominator. Then we set up a fraction for each factor. So we have one fraction that has x minus 3 in the denominator and one that has x plus 2. This is linear, so the numerator is just a. This is linear, so the numerator is just b. Then we multiply by the denominator on the left. So here everything canceled. For this first fraction, the x minus 3 goes away, but we're left with x plus 2. And in this one, the x plus 2 goes away and we're left with x minus 3. That's always going to happen, that you're left with your constant times some factor. Okay? Okay, let's keep going. We need to solve for the constants. So I'm going to go to the next page and I'm going to rewrite this. We have x plus 7 is equal to a times x plus 2 plus b times x minus 3. Okay, there are two ways to solve for the constants, okay? The first method is going to be the easier method, but it does not always work, okay? So if you want something that always works, go to method 2. And we'll talk about what problems it works for and what problems it doesn't. Okay, this first one we'll call elimination. The reason why we're calling it that is because we are eliminating constants in order to find what's left over. So what we're going to do is we're going to plug in values. That will make all but one of the constants disappear. And here we only have 2, okay? There are only 2 constants. There's a and b. Might be some cases where you have a plus c, okay? This original fraction only had 2 factors. It's possible that you might have one that has 3 factors, okay? We're not going to get a lot of those in the problems that we do, but it's certainly possible. So all but one of the constants disappear. Then solve for the remaining constants. And what you're going to do is you're going to repeat the process until you found all the constants. Okay, so let's do this method first. What we want is we want to solve for A, which means we want B to disappear. How can we make B disappear? Well, if we multiply B times 0, then it disappears. So how do we get B times 0? If we plug in x equals 3, then we wind up with B times 0, and B times 0 is 0, so it goes away. Okay, so let's start by plugging in x equals 3. So you'll see what we mean here. If we plug in x equals 3, then we have 3 plus 7 is equal to a times 3 plus 2 plus b times 3 minus 3. Well, 3 plus 7 is 10. 3 plus 2 is 5, so we get 5a. And 3 minus 3 is 0. So we just get 10 is equal to 5a plus 0, or 10 equals 5a. So we multiply b times 0, making it disappear. That's how we figured out what x to plug in. Because if we plugged in any other x, this would not disappear because we would not get b times 0. Okay, let's keep solving. Divide both sides by 5. And we get that a is equal to 2. Okay, now you have two options at this point. No, sorry, you only have one option. We found out what a is. Now we have to find out what b is. So we need a to disappear. So don't look here. Go back to your original. We need a to disappear, which means same thing. We need to multiply a by 0. And if we can multiply a by 0, then we're just left with b. So what can we do in order to get 0 here? We put in -2. So we're going to plug in x equals -2. So x equals 3. B disappears. And for x equals -2, a is going to disappear. Okay, and you'll see that -2 plus 7 is equal to a times -2 plus 2 plus b times -2 minus 3. So -2 plus 7 is 5. A times 0. Or let's just write it as 0a like we did it on the other side. I'm just going to rewrite that. So 5 is equal to 0a. And then -2 minus 3 is -5. So we have minus 5b. Okay, 0 times a is 0. So 5 is equal to 0 minus 5b, or 5 equals -5b. Divide both sides by -5. And we get that b is equal to -1. So our solution is that x plus 7 over x squared minus x minus 6 is equal to a over x minus 3, but a is 2. So 2 over x minus 3 plus -1 over x plus 2. And another way of writing this so that we don't have a plus -1 is this is actually a difference of fractions. And this is how we would write the solution. And this is your first method. Again, this is easier, but it doesn't always work because it's possible that you won't be able to eliminate all coefficients except for 1. Okay, all constants except for 1. It will always work in a case like this, where you get something that looks like this. Okay, a constant over a linear factor plus a constant over another linear factor, and there's only two fractions. It starts to not work when there's more than two fractions. Okay. Second method, I consider a little bit more complicated, but it always works. And some of you will like the second method better and will use it all the time. I do not care which method you use. So the second method, so we're using the same same fraction. So it can be more complicated, but it always works. And the second method is called equating coefficients. So what you're doing here is you're distributing, and then you're going to rearrange all of your terms so like terms are together. And the exponents of x decrease. In other words, you are in standard form. Then what you can do, and this is where the equating coefficients comes in, is you're going to set the coefficients on the left equal to the corresponding coefficients on the right. And I realize that a lot of this makes no sense because you haven't seen it. So it will make sense in a second. And you're going to solve it. And sometimes you have to solve a system. Okay, sometimes it's a system of equations that you're solving. I say sometimes because in some cases, when you equate them, it works out so well and you don't have to worry about anything, and it's not really a system because you're given enough information. And you'll see examples of this as well. And this is really what makes it more complicated, is that you do often have to solve a system of equations. Okay, so what do we mean by all of this? Because right now it probably makes very little sense. So let's start again with this original, and we'll use method 2. So we have x plus 7 is equal to a times x plus 2 plus b times x minus 3. So remember what we said. The first thing that we do is we distribute. So we're going to distribute the a and we're going to distribute the b. So we get ax plus 2a plus bx minus 3b. So we distributed. Now we're going to rearrange it so that the powers of x are together. So in other words, ax and bx both have a power of x that is equal to 1. So we're going to put those together. And then 2a and negative 3b have no x. So we're going to put those together. So we get x plus 7 is equal to ax plus bx plus 2a minus 3b. Okay, so we distributed. And then we rearranged so like powers of x are together. Then we're going to factor. What does that mean? X plus 7. We're going to factor out the x, and we're going to put the x on the outside of the parentheses, on the right side of the parentheses. So in other words, it's going to look like this. In front of the x's, we have a plus b. Okay, so we just took out the a plus b, and we put the x off to the side. And then what I would do is just all of your constants, just put them together. Okay. In this case, the coefficients of x on each side must be equal, and the constants on each side must be equal. So we're equating them. So this is the constant on this side because it has no x attached. This is the coefficient of x. On this side, this is the constant, and the coefficient of x is 1. So what we're saying is a plus b is equal to 1 because they have to be equal on each side. If the coefficient of x is here is 1, then the coefficient of x here is 1. So we would say a plus b equals 1. And for the same reason, 2a minus 3b has to equal 7 because this is the constant on this side. It has to equal the constant on this side. So 2a minus 3b is equal to 7. This is a system of equations. So we need to solve for a and b by solving the system. And you can see this is a lot more work. It's not hard, it's just a much longer problem when we do it this way. So our first step would be just to, we could just multiply everything by 3 here. We get 3a plus 3b is equal to 3. 2a minus 3b is equal to 7. Those cancel. We get 5. What did I do? I just want to make sure I didn't make a mistake. No, I didn't. We get that 5a is equal to 10. Divide both sides by 5. If you are struggling with the system, go back to the video from the first unit on systems of equations. So we get that a is equal to 2. Plug back in. 2 plus b is equal to 1. B is equal to -1. You can subtract 2 from both sides. And then you would just plug it back in. Okay. So x plus 7 over x, let me do this in red. This is just from the other page. X plus 7 over x squared minus x minus 6 is equal to 2 over x minus 3 minus 1 over x plus 2. Okay, let's try another one. Let's say that we have x minus 8 over x squared plus 7x plus 12 is equal. Okay, so we want to do a partial fraction decomposition. First thing that we do is we factor. So x minus 8 over x plus 4 times x plus 3. So that's our first step. We factor the denominator. So our next step is to write our fractions. So we have x minus 8, x plus 4, x plus 3. We're going to write this as two fractions, one for the x plus 4 and one for the x plus 3. And keep in mind that this makes sense because when you find the common denominator, you get x plus 4 times x plus 3 as your common denominator here. And you're saying, okay, well, I need numerators that where when I add them, I get x minus 8. So that's what's going on here, okay? We're trying to make this work like that. So we're breaking it up into two fractions. X plus 4 is linear, so it gets an A. X plus 3 is linear, so it gets a B. So separate the fractions. And then multiply everything by the denominator on the left. So we're going to multiply by x plus 4, x plus 3 on both sides. And on the left, and this will always happen, the denominators cancel. On the right, so if the denominators cancel, we get x minus 8. On the right, when we multiply this by x plus 4 times x plus 3, the x plus 4 cancels. So we're just left with a times x plus 3. And then for the second one, the x plus 3 is going to cancel, so we're left with b times x plus 4. Okay, so let's use method 1, and then we'll use method 2. Okay? So I'm going to rewrite this on the other side of the page. So method 1, plug in values of x to eliminate constants right? All but one of them. So you're asking yourself, what could we, this is an A, by the way. Okay, what can we plug in for X that will make this 0? Because then we'll eliminate A. Well, if we plug in -3, the opposite of this number, -3 plus 3 is 0. So we're going to plug in X equals -3. This eliminates A. -3 minus 8 is equal to A times -3 plus 3 plus B times -3 plus 4. Well, -3 minus 8 is -11. Then we get 0A plus B. Or -11 equals 0 plus B. Or -11 equals B. Okay, so we solve for B by eliminating A. Now we're going to solve for A by eliminating B. So we're going to plug in X equals -4 this time. So that eliminates B. So -4 minus 8 is equal to A times -4 plus 3 plus B times -4 plus 4. -4 minus 8 is -12 is equal to -A plus 0B. -4 plus 3 is -1. That means -12 is equal to -A plus 0, or -12 equals -A. That just means that A equals 12. So if we write out our solution, x minus 8 over x squared plus 7x plus 12 is equal to 12 over x plus 4 minus 11 over x plus 3. So remember, the minus is instead of plus negative. Now, if we want method 2, method 2 is going to equate coefficients, so we're going to distribute. We're going to rearrange. And then we're going to equate coefficients. And solve. So we're starting from up here at the very top. We distribute the A, we distribute the B. We get x minus 8 is equal to AX plus 3A plus BX plus 4B. Rearrange it. X minus 8 is equal to, put the AX and the BX together because they both have an X attached, and put the 3A and the 4B together because they don't have any X's. Now we just factor out, right? So we factor out the X, making it A plus B times X. And then we just put this 3A plus 4B in parentheses, just so that you're clear that that whole thing is the constant. So A plus B equals 1. And 3A plus 4B is equal to negative 8. You can solve this system however you want. If you do it with elimination, then you can multiply the first equation by negative 3. Negative 3a minus 3b equals negative 3. 3a plus 4b is equal to negative 8. Add them, the a's cancel. We get b is equal to negative 11 again. And then just plug in, right? A plus negative 11 is equal to 1, or a minus 11 equals 1. Add 11 to both sides, a equals 12. And you wind up with the same answer, right? You should. X minus 8 is x squared plus 7x plus 12 is equal to 12 over x plus 4 minus 11 over x plus 3. And I'm going to stop there for now. And there will be a second video on partial fraction decomposition, which will do more of this, okay? It'll do ones with multiple, with more than one fraction, more than 2 fractions. So it'll be 3 fractions, okay? And it will also, where you'll have to use the second method in some cases, okay? You won't have a choice. And we'll also talk about how to break things down when you have something quadratic. So we'll do some solving for constants, but then we'll do some where you don't have to solve for constants at all. So that'll be in the next video.